All right, we'll continue with the answer key to the practice final for Calculus 3. Number 6 is where we are. You have first first, number 6 has two quadratic surfaces. One, by the way, they both have squares, x, y, and z all have squares, and they're just all you see is a plus sign. So that tells you that this has to be an ellipsoid. Okay, whereas this one has that part B has negative, and so that's not going to be an ellipsoid. That's probably an hyperboloid or something like that. All right, let's go and do A first. For each of these, what you have to do is to draw, practically, you have to draw three traces. Okay, so let x be equal to 0 first. Then you see the cross section of this particular surface when you cut it along x is equal to 0. So this is it's a parabola, right? No, it's a, sorry, it's an ellipse. And you can draw a small sketch here. You don't have to have a big one. But what is that? When x is equal to 0, so that means you are actually on this, what I call a canvas. Here's a canvas, x is equal to 0. Right? And this really helps, I think, if you follow this kind of a convention. So this means y, 1, z plus some negative, possible negative 3. These are the intercepts of the ellipse. So this is a wide ellipse, that's a horizontal ellipse, where the, oh no, that's not right, right? Okay, so this goes this way, and +3 and positive and negative 3 along the z-axis, and positive and negative 1 along the y-axis. It's going to be a horizontal, no, vertical ellipse. Okay. If y is equal to 0, you have x squared over 4 plus z squared over 9 is equal to 0. Now, which canvas are we talking about here? Well, the canvas here, when y is equal to 0, is that canvas. And on that canvas, I'm going to draw another ellipse. This time, x squared over 4 means I have to go 2 units to the up and to the front and the back of the origin. The top is still positive 3 and negative 3. So this is also an ellipse, but it's a slightly wider one, right? 3 here and 2 and negative 2 here, like this. If z is equal to 0, you have x squared over 4 plus y squared over 1 is equal to 1. And this time, of course, your canvas is the floor, right? So this is the xy plane, because z is equal to 0. And you take plus and minus 2 in the x direction, positive and negative 1 on the y direction. This is a kind of a small ellipse. Right. Now, what's important is you can't leave it here. Okay. What I need you to do is to combine all of these. And you already know this is going to be an ellipsoid. So you can go ahead and try to, do this. You don't have to. Once you have these traces, then I don't need to see your finished product with the XYZ axes, right? So this is what you get. It's pretty much that, right? If you want to add your coordinate planes or something like that, that's okay. And it should be, maybe a little longer in the x direction, but this is going to be okay as long as you have these traces. And so this is an ellipsoid, as I said before. Okay. All right, so that's the idea. For part B, it's somewhat similar, right? But there is a big difference, I think, in two of these traces. If x is equal to 0, you have y squared over 1 minus z squared over 9 is equal to 1. Now, do you remember what this is? Again, I'm going to define my canvas on which to draw the trace. And so this is going to be an hyperbola because the sign between the two terms is negative. And so y direction, you go 1. And in z direction, you go plus or minus 3. But you don't you don't draw anything in here. This is called a what I call a guiding rectangle. And you can also draw these diagonals. Okay, the guiding rectangles are guiding because they give you a point. They give you sort of a not to enter, do not enter region. Okay, so the hyperbola is not going to go inside of the rectangular region. Y is first. What does that mean? That means that this is a horizontal hyperbola. Okay, where the one, this is a positive. The first one is the positive term, which means that the graph is going to cross, the hyperbola is going to cross the y-axis, but not the z-axis. So this is the picture when x is equal to 0. Next, let y equal 0. You get x squared over 4 minus z squared over 9 is equal to 1. This time, your canvas goes this way, right? And so this time, you go positive and negative 2 units in the x direction, positive and negative 3 in the y direction. You do the same thing. This is a rough sketch, as you can tell. All right. This time, again, the positive term has x in it, so the hyperbola will cross the x-axis, not the z-axis. So it'll be a little wider one, or the distance between, these two components of the hyperbola would be 4 rather than 2, like in here. All right, and then if z is equal to 0, sometimes this will give you an empty set. I don't think that would happen here. If z is equal to 0, you have x squared over 4 plus y squared over 1 is equal to 1. And now you have the positive sign in between them, and that's because in this case, the canvas is the horizontal plane, and the cross section will be not an hyperbola, but an ellipse, right? 2 units, negative 2 units, one up here, oops, one up here, one here. And so it's going to be a horizontal ellipse like this. Okay, now you can combine all of these, and you can see it's going to be an elliptic hyperbola. The name convention, remember, is whenever you see only one ellipse and 2 hyperbola, that's going to be an elliptic hyperboloid. Correct myself. All right, so the answer is going to be something like this, and you can draw a little picture like this. You have seen this many times. Okay, I grew up with one of these things, right? Remember, the port city of Kobe, Japan, has this iconic symbol at the harbor, and that is called the Port Tower of Kobe. It looks exactly like this. Well, not quite. It's a circular hyperboloid. This one is an elliptic hyperboloid, and this is an ellipse, not a circle. Elliptic hyperboloid. All right, so that's how you can sketch these, and that is number 6. All right, next we go to 7, and let's do 7 and 8 together. 7, Cartesian coordinates are given for a point, and we are to change or convert the coordinates into cylindrical coordinates. Right now, what's cylindrical? Well, cylindrical has r, theta, and z. Now the z is the same, so you know the answer. One of the answers already. Z has to be 3. We just have to find r and theta, right? Let's go do that. So there are formulas, and I keep telling you, don't depend on these formulas. Sure, for random points, you may have to use formulas, but my emphasis is for you to really understand this visually. So my questions will probably just depend on not the formulas, but how you can think about these questions, think about these points. So what's 1 square root of 3? Well, x is 1, and y is square root of 3, right? I know the z, so I'm not going to even worry about that. So this is the point I'm talking about, okay? And so this point, and this is x, y, z in the 3-dimensional space. If you think about this as a 2-dimensional point, x and y, you have this 1, and you have a square root of 3. And so we're talking about this this line here, or the line segment, and this angle, right? So what's r? Well, r, as you know, is the square root of x squared plus y squared. That's a polar length from the origin to this point. All right, so this is going to be a square root of 1 plus 3. That's this square plus that square, right? And that's, of course, square root of 4 or 2. The length of this line segment from 0, 0 to 1, comma, -3, obviously is equal to 2. That's one of the standard triangles. One of the first things you learned in trigonometry, right? Okay. Theta. What is theta here? Well, it's the angle in the first quadrant whose tangent is square root of 3. Do you know this angle? I hope you do. That's pi over 3 or 60 degrees. So the answer to this question would be 2 pi over 3. Z is the same, right? So Z remains 3. And that is the answer to this question. Number 8, you are given the spherical coordinates, and you are supposed to come up with the Cartesian coordinates. All right. This is rho, this is theta, and this is phi. All right. Immediately, I know this phi is equal to pi over 2. That's this. Okay. Wherever this point is, from the positive z-axis, you have to go pi over 2 radians opening up. And whichever the point you go to, it's going to be on this plane, xy plane, right? So I know that the z, this tells me that z must be equal to 0. Okay, that's one thing that you should notice right away. Rho is 1, and theta is pi. Pi means you go from the positive x-axis to the negative x-axis, right? And you go the distance of 1. So this is really the point I'm talking about, all right? Does it make sense? Okay, let's try to do this again. This tells me that from the origin, you go the distance of 1, whichever the direction you go, right? And the horizontal direction is sort of telling you here, is told by theta equals pi. So it's 180 degrees from the positive x-axis going counterclockwise to the negative x-axis. All right, and then of course we still don't know, where it is in terms of phi, but phi is pi over 2. So from this positive z-axis, you go down pi over 2, and you end up at this point on the xy plane. So what is that point? 1 unit away from the origin, where theta is 180 degrees, which means it's on the negative x-axis. So the answer has to be -1, and then the y coordinate is 0, z coordinate is equal to 0. So that's the answer to that question. All right. Again, my questions will not require you to know the formulas, but you do need to know how to analyze and figure out these points, sometimes based on trigonometry, sometimes just based on your spatial knowledge. Okay, let's go to the next question. All right, number 9. The question is to sketch the region whose area is expressed by this integral. Notice here it's in the form dx dy, and looks like from these bounds you can see that first I know that y goes from -2 to +2, and for each, so that's from -2 to +2, and then for each y, x goes from negative square root of 4 minus y squared to positive square root of 4 minus y squared. So the equation to analyze is this equation. X is plus or minus 4, a square root of 4 minus y squared. And of course, if you square this, you get a simple equation, which is x squared plus y squared is equal to 4. You may have already recognized that by looking at these bounds, but this is a circle of radius 2, right? And so it goes from a negative to positive. So this, for each y, it goes from this half circle to this half circle. So this is going to give you a complete circle of radius 2. Okay, but I do want you to know what this order means. Okay, this order means y goes from -2 to +2. And for each y, let's say you pick a y here, for this y, like maybe 1.2 or something. For that particular y, x goes from negative square root of 4 minus that y squared, that's this point, and then to the other endpoint is the square root of 4 minus whatever that y value is squared. So it's here. So that's the length we are talking about. And you do this for every y between -2 and +2, right? So the answer, well, okay, the answer is going to be, maybe I should be a little more careful here. The answer is going to be something like this. You know, you want to sketch these correctly. And so I will try to do this, right? Okay, so it's nice to have these computerized drawing tools, but you don't have to. Okay, what you want to say is that it's going to be a circle. And of course, the area of the circle is going to be 4 pi, circle of radius 2, centered at the origin. Okay, so that's the region whose area is expressed by this double integral. All right, so let's go to number 10, and then we'll take another break before we go to number 11. E in this question, number 10, is a solid. Okay? And we are to find the volume of the solid by writing a triple integral that represents the volume of the solid E. And what it says here is that x is greater than or equal to 0, y is between 0 and 3, z is between 0 and 2 minus x. All right, so what does that mean? Well, this is the most complicated thing here, right? So what is that? Z equals 2 minus x, that's x plus z is equal to 2. You may want to sketch that. What is that? That thing, okay? And that is, of course, a plane, right? The fact that y is missing means it kind of goes this way infinitely in the both the negative y and y direction. But x plus z is equal to 2 means you have 2 as the x-axis, I mean the intercept, and 2 as the z-intercept. So it's actually this line extended in the y direction like this, right? So that's your plane. So this actually helps if you sort of picture this, right? So this is that it's a plane that makes a 45-degree angle from the xy plane, and this is this equation here. Okay, now let's, with that in view, or with that in mind, let's go back and look at this. You want x to be in the positive, so forget the backside. All we are talking about is this direction here, right? So it starts here, going in this direction. Y goes from 0 to 3. Oh, that's good to know. 1, 2, 3. And so it ends here like this. Okay. And then z goes from 0, that's this xy plane, to whatever, whenever it touches the roof, which is z is equal to 2 minus x, right? So the picture you have is basically that, right? And so I'm not going to redraw this, but the solid E is actually this triangular object, like the prism, like that. Okay, now let's verify this. X is always non-negative, so you know it's the front of this. And then y goes from 0 to 3, and then z goes from 0, which is the xy plane, to where whenever you touch this surface, right? So this is exactly the picture of E, the right picture of E. All right, so now let's go ahead and write, let's see. The problem says write a triple integral that expresses the volume, right? So if you just read that part of the instruction, it seems like you can do any, you can do x, y, z in any order, but the problem goes on to say use the order dx, dy, dz. All right, so z has to be defined first. Z goes from 0 to 2. That's pretty obvious. This entire solid E goes from z is equal to 0 to z is equal to 2. Now, for each z between 0 and 2, y goes from 0 to 3. In fact, y is independent of z. And then for each z and y I pick, x goes from this point to whenever it touches this roof, right? So x, because x starts at 0, x goes from 0 to whenever it touches that surface. So now we have to solve this equation for x. Well, that's easy, 2 minus z. Right, so x goes from 0 to 2 minus z. This may be the trickiest part of this problem, but you have done this before in chapter 5, and I hope you do remember how to do this. All right, so with that, can you write the equation? Can you write the answer? Yes, I think so. The volume is the triple integral from 0 to 2, another integral from 0 to 3, the innermost integral goes from 0 to 2 minus z of, there's nothing to integrate inside, right? It's just the one, the density function basically is 1. And then you follow this order because this has to do with x, next one has to do with y, and outside it has to do with z. So now we have finished writing a triple integral that expresses the volume of E. Now, what is the volume? Well, you can find it in 2 different ways. One way is to simply work on this integral. 3 is not here, so you can just put 3 here, 2 minus z, dz. And so let's take the 3 out. You get 2z minus 1/2 z squared going from 0 to 2. This part I'm confident you can do easily. So this is 3, and then 4 minus 2, right? Because it's 1/2 times 2 squared, which is 2. This part is going to give you 4. So that's 6. But of course, you knew this is 6 because the volume is also, I mean, we're talking about 2 by 2 by 2. Sorry, 2 by 2 by 3. And half of that, right? So it's 1/2 of 2 times 2 times 3. That's 1/2 of 12, and that's 6. So that is the answer to that question. All right, so we have finished the first 10 of the 19 questions in the practice exam or practice final. We will do the next 5 in the next segment, and then the last 4 in the last segment.